We have a wide variety of adapters that go from a 240 volt outlet, like a 4-prong dryer here. We actually have it back here too. And they actually distribute power to regular 110 outlets. And we have a bunch of different ones like that. And people kind of get confused on how the HOTS work in relation to the amperage, and if you can power X amount of amps, or if you can't, if it doubles, if it gets cut in half. It's a question we get a lot. And so we're going to explain to you exactly how the HOTS work in relation to the amperage in these adapters. Okay, so the explanation starts back at the breaker box. So if you look behind me, you'll see a duplex breaker and just a single breaker. And I've actually got one here so you can kind of see it closer. So the duplex breaker is bridged because when you turn off this breaker, you need to turn off power to both HOTS, not just one. And so with this, again, you'd have two HOTS. So for this example, say this is a 30 amp breaker. You'd have a 10 gauge hot and another 10 gauge hot. So when you turn this off, or trips or whatever, power to both HOTS will turn off. Okay, so the same rule with the HOTS applies here. 10 gauge, 10 gauge. And they go down one to one side, one to the other. Still only 30. So it's still only 30. It's not going to be 30 plus 30 is 60. It's not going to be 30 divided by 2 is 15. It's still just 30. And we can kind of demonstrate that here with the setup we have. We have a bunch of fans, heaters, etc. And we have kind of a half dissected adapter. It's the same thing as this, just a little cut open so I can get some measurements. Okay, so here we have a multimeter, and then again our dissected adapter. When you can see I'll remove this for a second. Two hot wires are red and black, and then ground neutral. So the red hot wire, 10 gauge, goes to this side, black goes to this side. And again, we have a couple different random heaters, blowers, you name it, just to kind of show you how much power is going to be used, because it'll actually add up to over 30 and it'll keep running. Okay, so we'll turn on this one. So right off the bat, this blower over here that's connected to this side comes out to about 19 amps. Okay. Now we'll go to the other hot, the black, and the red one is still running. So that up. We're at almost 0. Okay. So that's a hair dryer. That's on the hot setting, almost 14 amps. And then we have another portable heater hooked up. We'll put that to the highest it can go. Should kick on in a second. Okay, you can see it's starting to climb. So again, the black goes to this side. So it's almost 25, going over 25 amps actually. So 25 amps. And then you have the 19 on that side, and it's still going because it's 30 per each hot. 10 gauge is rated for up to 30 amps per hot. So it's not 30 plus 30, it's just 60, it's not 15, 15, it's just 30 and 30. So another way to explain that, if that's kind of confusing, is that this is basically two separate circuits. 4-prong connections usually have two separate circuits unless they're 3-phase or something more special. But again, sticking with this 4-prong dryer example, ground, hot, neutral, hot. So it's 240 volts. This side, 120. The other side, another 120. So each circuit So that'd be, again, the ground, hot, neutral, ground, hot, neutral. That's 30, so the 10 gauge, 30 amps. Same with the other side, 10 gauge, 30 amps. Two separate circuits of 120 volts. Okay. And we have a bunch of other products that are similar to that, or they just go from a 240 volt outlet to 120, and they still follow the same rules. But if you still have questions on this, because it's kind of confusing, please leave a comment down below. Otherwise, be sure to give us a like and subscribe. Thank you for watching.